All right, welcome all. We are going to talk about solving absolute value equations. Let's add that up at the top here. I don't think it's up here. Just make sure it rates first. So we're going to be talking about solving. Yesterday we solved by graphing, which we're going to start with today, and then we're going to see how to do it algebraically. And we also will deal with absolute value inequalities, which is something we need to pay attention to. It can be kind of tricky. All right, so yesterday we learned that these two things here, our h and our k, give us directions on where to move the vertex of the absolute value. We learned that k moves our vertex up and down, and it was direct. So if it was a negative, it meant that it moved it down 7. We also learned that if h was on the inside here, it was affecting x directly, that it was the opposite of what we planned. So even though this looks like a positive 3 and we should be moving to the right, really h is telling us to go to the left 3 units. And k is telling us to go down 3 units. So that's going to be our first move here to do the vertex. So we're going to go ahead and go down 7 units. So 1, 2, 3, 4, 5, 6, 7. And we're going to go over 3 units. 1, 2, 3, and that's going to be our vertex right there. And then from there, we're using the parent function idea, and this is a kind of a vertex form movement. So we're going to repeat that pattern, which was up 1 over 1. There's no negative, so it doesn't flip. And we're just going to duplicate this pattern on both sides because it does have symmetry. To review just a couple quick topics that we've talked about previously. We'll see how good I can draw a straight line on here. We should just fill that in. Oh, a little wonky, but it'll work. And we'll duplicate on the other side. Not the best graph, but we should still be able to kind of find the solutions. I'm going to cheat a little bit. You can see how bad my graph was. Let me change this color so we can see it nice and clear. Our solution then should have been right here. And we have to extend this line by 1 unit over because we're 1 unit short. Again, if you watch my dots here, that should be the second solution. So we should be able to find both. This is a 10 by 10 graph. So what we find is that this first solution on the left side is really negative 11 and 0. And what we find here is that it should be 4 and 0. Now the only reason that we review this is because now we're going to explore it algebraically. These should go right here. Now we're going to try to explore this algebraically. Algebraically, as we mentioned yesterday, that these are very similar to a linear function, and really we can treat them the same way when we solve. So if we take that function, that first real function that we had, and we go back and make sure that we can see it, it should be the absolute value of x plus 3 minus 7. So let's write that down and see if we can solve this algebraically and get a better understanding of what we're going to do for the rest of our problems. So there's the function again. Step 1 when we do this, well, I guess before we show step 1, maybe we should talk about what we're doing and why we're doing it. So here's a quick little example to kind of figure out, see what we're going to do to solve it algebraically. Let's just look at this basic function. The absolute value of x equals 4. Not a lot to it, but this is what we're going to think about. Okay, so think this. So now that we've got that, we're going to take this function. What two values of x can make this true? Well, that's pretty simple. We know absolute value does strip off the negative sign. We talked about it being a distance, so really we're not concerned with which way we're going with an absolute value as more as how far away it is. So in this case, there's actually 2 distances away from 4, or 2 distances of x that can create this. So if we look at it, the first value of x can equal positive 4. All right, if we plug positive 4 in there, 4 does equal 4. But in this case, also x can equal negative 4, because the absolute value of negative 4 is also 4. So we get really 2 versions of this absolute. We get a positive form of it, and we get a negative form of it. And that's what we have to use, this concept right here. We have to use this concept when we go to solve algebraically, that there's going to be a possible negative form and a possible positive form. So we're going to solve 2 forms when we look at this one here. But before we start that, we have to get the absolute value by itself. So here's our rules for solving for absolute value. Okay, rules, we'll keep them real simple. So rule 1 is going to be that we first need to start and solve for the absolute value all by itself. So while it's not a variable, we're going to pretend that the absolute value is kind of a variable, and then anything that's attached to it, we're going to use our reverse order of operations. We're familiar with this, right? And we're going to solve for, again, using inverse operations. I guess I should mention that too. We're going to solve for the absolute value. So we're going to get it by itself, isolated on one side of the equal sign. And then after that, we're going to go ahead and address the positive form and the negative form. So let's get these two basic rules down so we can get started. Oops, I should have, let me erase that real quick. All right, so then our first rule was solve for the absolute value, again, meaning isolate the variable. Okay, and then step 2 then was to address the positive and the negative. So we're going to solve two functions after that. We're going to solve a positive and a negative function. So solve, ooh, that's rough on the solve there. Two functions. Okay, and let me switch colors here and we'll do underneath, we'll solve for a positive one. And we're going to solve for a negative one. Sorry if that's hard to see. I'll scroll that up real quick. All right, so that's where we're going to start. When we're all done, we will solve for the variable itself. So there's kind of 3 solvings in each of these. So now we're going to write solve for variable. So we're going to solve once for the absolute value, then we're going to break it apart and solve for the positive version and the negative version, and then finally we're going to solve for that variable in each of those so that we end up with the 2 possible solutions. And what we should see is that we should come up with negative 11 and 0, and we should come up with 4 and 0. That's what we should find when we solve this in algebraically. So let's go ahead and attempt to do that. So first we need to solve for the absolute value. And you can see that if this is the absolute value or the variable, pretend variable, this 7 is attached to it. So according to our reverse order of operations over here, it says that we would do any distributive properties. So if there's any multiplications here, we'd get rid of those first. And eventually we'd end up with addition and subtraction. So we're going to move this 7 over. And we're going to move it to the other side. Now we've got our absolute value solved for. Now we're ready to go to step 2, which means we're going to solve 2 versions of this function. We're going to solve a positive version and a negative version. Just like we had a positive 4 that could go in the absolute value and make 4, and we had a negative 4 that could go in the absolute value to make 4. We're going to have 2 versions of x plus 3. We're going to have the positive version of x plus 3. Let's write that now. So here I'm going to do it in red, kind of keep it together. So it's going to be x plus 3 equals 7. That's the positive version. And we got to go back and solve for our other variable. So, and we're going to solve for our negative version of the variable, which means we need to take that whole quantity, x plus 3, and make the whole thing negative. You got to remember to put that in parentheses. We don't do it for the positive because there's nothing to multiply to it, so it doesn't change it. We could put it in parentheses. There'd be nothing wrong with that, but it's just not necessary. They could be there, but not necessary in this case. Now we've got our 2 forms of our linear function here. Right? We've addressed the absolute value by writing these 2 forms, one positive, one negative. Now we can solve for both. We're in step 3 here. We're solving for that variable. And it should give us, again, that negative 11 and that positive 4 when we're all done. So let me switch back to red here, and let's solve this one. This should be pretty simple. There's no multiplication. The only thing that's done to the x there is at 3. So we'll go ahead and subtract 3 on both sides. And we find out that x is equal to 4. Or better yet, we're understanding that a solution then is a x-intercept, or 4, 0. That seems to match our point here. So far, so good. So now let's switch over and solve the negative one. We could distribute this negative, but there's an easier method if we just go ahead and move the negative, and we're going to want to use this later also when we get to the inequalities. We'll want to, instead of distributing it, we know that we don't always want to. Sometimes tying it up doesn't make any better. Is it bad if you do it? No. I just think this is the better method to take. So the 2 negatives become positive, and the 7 is going to switch its sign. So we're going to end up with x plus 3 is equal to negative 7. So now we're ready to solve. Pretty simple solving again, minus 3 to both sides. And we get x is equal to negative 11. And let me scroll up a little bit so I have some room. And we find out that the point negative 11 and 0 does match the one that we did graphically. So it holds up true from what we saw yesterday in the graphing for it. Now you can see how to address it by algebraic methods. Again, these are key rules. And all of you are going to write this in that little box that goes on the back of your stamp sheet. That's the point of this, right? These are the key things that you want to find. So there's a rule. Solve for the absolute value, then break it apart into a positive and negative version of whatever is inside the absolute value. If it's x, it's x. If it's some quantity like x plus 3, you solve it positive and negative. Make sure that you use parentheses, especially for the negative side, and then solve for both of the variables if there is 2. All right, so let's practice that again. Let me scroll this around here, and we're going to keep this moving. I'm going to try to keep this video as short as possible for you. All right, so first things first, step 1, make sure that your variable is solved for. You can see here there's nothing multiplied, subtracted, added, or divided to the absolute value, so we can just go ahead and write both versions, positive and negative. Now we're on to step 2. So here's the positive form, 3c minus 6 equals 9, and we're going to solve. You don't really need to write the and. This is just to make sure that you see that the two versions are happening. The negative version. Again, use parentheses. Otherwise, you'll make a mistake there. Right? You'll end up with a negative 3c and not a positive 6 here that we should get out of this. And so we got our two versions. Now we can solve for the variable c. So we'll go back and solve the positive version first. So we're going to add 6 to both sides. We're going to get 3c is equal to 15. Divide by 3 on both sides. And we find out that c is equal to 5. Again, if we write it as a point, just so that we keep that understanding, it's the 0.50. Now we can go back and solve for the negative version. Again, instead of distributing, we're going to just divide by negative 1. They turn positive. Divide by negative 1 is going to change that 9 to a negative 9. So we get 3c minus 6 equals negative 9. Again, we can finish solving pretty quickly. Add 6 to both sides. 3c is equal to negative 3. Divide by 3. And c is equal to negative 1. Or, let me scroll up a little bit. Or the point negative 1, 0. And we could graph this. You'll notice this looks like one of those problems yesterday where there's a 3 here. And if you, we didn't talk a ton about that, but it's not necessary at this point because now we can solve it algebraically. When I get back in class, we'll talk a little bit more of that graphically so we can kind of understand it. I'm going to keep moving here. There's a few other examples. I'm going to probably scroll down to one that looks a little bit more difficult for us because I want you to see a couple different examples before we move to inequalities, and that will be what's next. You'll notice that most of the ones that we're looking at here only have one operation tied to the absolute value. This one doesn't even have anything. This one has a 2 multiplied to it. There's a negative 3 over here, a 7 here. Let's do 6. 6 looks pretty good. So we'll do 6. Again, if you want the full set of the notes, they're already done. They'll be posted online for you sometime tomorrow. I don't think I'll get them up tonight. But you can look for the full section of the notes if you want to go back and review them. And I'm going to pause here to say definitely go on to the YouTube channel and check out the videos that I have for you. Get to see at least 3 other examples of this. If you go on there, if you get stuck when you get home. So go back to our rules. Rule 1, solve for the absolute value. So we're going to solve for this. To get rid of this 7, we're going to divide by 7. Let me go back and make sure that I have a black color here. I'm going to divide by 7 to both sides, right? Keep my equality true. So I'm divide by 7, those turn into 1, leaving my 2 forms, or leaving my absolute value of n minus 14, which I'm going to get my 2 forms from, and 28 divided by 7 is just 4. All right, so now the absolute value is isolated. Now we can write our positive and negative version of it. So our positive version is going to be n minus 14 equals 4. And then my negative version of it, I'll skip the and part now, is a negative n minus 14 equals 4. We're going to solve both of those. Since I'm in blue, I'm going to go ahead and solve this one. Divide by negative 1. You can see that gets a little redundant. But that's okay. We need it in a minute. So keep doing it. Okay, so if I go ahead and finish this out, this will be negative 4. And to solve this, I'm going to add 14 to both sides. And we'll find out that n is equal to, what do we get? Positive 10. And again, the point 10, 0 as an intercept. All right, so if we go back and solve this one, it's only a single step. If I add 14 to both sides, we find out that n's equal to 18, or the point 18, 0. All right, so pretty simple procedure. Again, solve for the absolute value, isolate it by itself. Step 2, write it as a positive and a negative, and then finally solve for the variable. All right, so that's with an equation. So these are all equal signs, you'll notice, right? Every one of these that we do is the equal sign. These all operate the same. This one actually has 2 operations. Whoops, that's okay. First thing first, you would add 2 and then divide by 3, and then you have your W there. But again, we've seen that, so we're okay. Now we're going to move on to the inequalities. This is, and I got it wrong, I told you guys it was notes 4, but this is the part that students struggle with the most, is when we involve an inequality with our absolute value. If we're comfortable with what we did above, understanding that we solve for the variable or the absolute value, and then we write it as a positive and a negative, we can skip these rules right here. I'm not huge on these rules because it's another tool of memorization. You can do that, and if you're fine and you've memorized the fact that if you have a less than sign, that you write it as less than the absolute value what's inside, and then greater than the negative of what's inside the absolute, or negative of whatever's not, or whatever the absolute value is greater than or equal to. And then that's an and statement. I should draw attention to that because it's a less than sign. And this is a little review. This is an or statement because it's a greater than sign. You can memorize these rules. And again, with the or, it's fairly similar. Greater than what's inside the absolute value, and then less than the negative version of whatever the absolute value was greater than at the time. But you'll notice here that the sign flips, and this becomes negative. I don't like that. Now that I've talked about it enough, let me show you exactly what I'm talking about, what I do like. I want to keep the same procedure that we did above, right? Isolate the variable, or isolate the absolute value, right? So solve for it. And then step 2 is where this comes into play, where we write a positive and a negative version of what's inside the absolute value. If we keep that true, this rule doesn't apply anymore, because this step 2 will take care of that for us without having to memorize this. And I'm a big proponent, or it's one of my main things, is that if there's one less thing that we have to memorize for math, it's probably better for us. So if we can create a technique that we're good, solve for variable, I don't know. Sorry, I got off track there. Just like in class. Whoa, that's not good. We lost everything. Let's get back and find it. There we go. So we'll solve for the variable third. So if we just keep these rules here, we're in a much better situation than I think memorizing this rule here. You'll see it in the book. You'll see it actually in the videos that I've put on there for YouTube. But I want you to ignore it, and I want you to just follow the procedure that we did up here. And I'm going to scroll back up to it because I really just want to make sure that I show it to you again. Again, solve for the variable, solve for 2 functions, positive and negative, and then solve for the other variable. I think I'm supposed to say absolute value there. All right, so let's scroll down and let's tackle one of these. You can use these notes as kind of a guide. I will show you one thing that is absolutely incorrect here. This is supposed to be this way. It's supposed to be a greater than or equal to sign. And the reason I know that is because it says or here. And greater than signs are ors, less than signs are less, and signs are less than. So, and that's nothing more than keeping track of what type of inequality we have. So shape-wise, when we solve this, because it's a or inequality, that we should have the unintersection, or I want to say the non-overlapping answers, right? And if it's an and, it will be the opposite, where we have the intersection. So that's the only thing that the and or really applies to here, or even in general. So this would be an and. Again, this is review. This is an or, right? Just shape-wise what it looks like in the answers. So all the answers that are excluded for an or, all the answers that are included for an and. So let's solve one of these now that we've done a lot of talking. And we'll keep them pretty simple. You'll notice there's not a lot going on with these. There's no solving of the absolute value first. All of these are already solved for. So, and I suspect you'll see the same thing in your homework. But if you didn't, make sure that you solve for the absolute value first. Notice that there is the inequality here. We should probably label this. It's a greater than sign, so we know that that's going to be an or statement. So I like to write or up there, and as soon as I write or, I just like to put a little picture in my head that I'm going to end up with a solution that should look like this. If I don't have this non-combining, non-intersecting solutions, then I know I made a mistake when I'm done, because we do have to graph this when we're all said done here. Okay, it does say to graph, so we will graph at the end. So since the absolute value is already solved for, we can go ahead and write two versions of it. Once with the positive version of what's inside the absolute value, and once with the negative. So here's the positive version. X minus 3 is less than 5. Nothing different than what we did above. All right, I'm going to switch to black here. I am going to put the or now because it's a less than sign. Or I'm sorry, it's a greater than sign. It's an inequality. It's important that we do label what type of inequality this is. Now I'm going to take that quantity inside, and I'm not doing anything different. I'm going to write it negative, just like we did before. So there's the quantity inside the absolute value, x minus 3, and it's negative. Keep your sign. Don't worry about those rules above. Don't change anything yet, because we're going to do it right here. Are you ready? It's like magic. We're going to do the same thing we did before. We're going to divide by -1. And what happens when we divide by a negative with an inequality? We have to flip the sign. Oh, that's a terrible flip. Let me fix that. I can't handle a bad writing like that. So we're going to flip sign. Oh, bad button. There, finally got it. So that takes care of everything that we had to worry about. That rule above, this takes care of it by just doing what we already know. Dividing by -1, when we divide or multiply by a negative to an inequality, we're going to flip that sign. So let's finish this blue one since it's the one that we're looking at. This negative's gone, so it becomes just x plus 3 or x minus 3. The sign now has to flip, correct? And it looks like a 7. It's really a -1. It's a 5 divided by -1 becomes a -5. So that rule above said that when you do this or inequality, that you get one with the quantity inside the absolute value, you flip the sign, and you make whatever it was less than or greater than, you make it, you flip the sign and you make it negative. So let's just look at that again. So here's the or, there's the positive version, nothing different. Here's the negative version, flip the sign. Notice it's a greater than sign here. Notice it becomes a less than sign. And notice it was a +5, it becomes negative. So if you follow what I've got going on for you, you don't have to memorize that rule. You just have to do what you already know how to do. And I think that that's the best case scenario. So let's now just finish this. So we're going to add 3 to both sides. So we find out that the x, or the solutions, are less than -2. And we don't write that as a point because now it's a range of solutions. It's more than one. Before it was a single intercept. Now it's a whole range. Let's finish this other side for the positive. So I'm going to go ahead and add 3 to both sides. I'm going to find out that x is greater than 8. Again, when I go to graph this, I should have this image. And that's what we're looking for here. So let me do a number line. There is a line generator on here, but this is good enough. My solutions are greater than 8 here. And my solutions are less than -2. So let's put my 0 here. There's my indicator 0. This will then be my -2. And then over here will be my 8. And it's rough sketch, but it should work. So these are greater than and less than signs, so not included. So I don't have to worry about filling in the circles, so these will be open circles. So we'll do the less than side. So there's my open circle, and my solutions are less than -2. So it should go down here. My green is not shown up very well, is it? So there's my less than 2. All my solutions less than 2. Here's the positive version. So I'm again open circle because it's not included. And it says the solutions are greater than 8. And that confirms the or part. So it's kind of like a check to call it an or and have that image in your head because that's the correct graph. It matches. I'm pretty satisfied with this, and that's the correct answer. We could double check by plugging them and making them a true statement. Time for this video, I'm going to go ahead and ignore that in this case because I think I'm already at 20 minutes, and that's a long time. So let me do one more quick one. Let's do an and statement. Here's an and statement one. I'm going to kind of go quickly through this one so you can just see it. I am going to label this to start though. So it's an and statement. Nothing changes. We're going to go ahead and write a positive version of it because the absolute value is already solved for. So here's the positive version. N plus 1 is less than or equal to 7. I'm going to put my and statement in between. Could we do this as a conjoined compound? Absolutely. But I'm going to keep the pattern here simple for you guys today. Here's my negative version. N plus 1. So we take whatever the quantity is inside the absolute value, we make it negative. At this point, we don't switch the sign because we haven't divided or multiplied by a negative. Here's that happening. Now I'm dividing by a negative 1, divide by a negative 1. That tells me I have to switch my sign. This cancels out, so I'm now left with n plus 1, switch my sign, negative 7. Again, it took care of itself for me. So I'm going to go ahead and finish solving for this one, negative 1 to both sides. So n is greater than or equal to negative 8. Let's go back and solve the positive version, minus 1. N is less than or equal to 6. It's an and statement, so I should have a barbell-shaped answer. It should be the intersection, the overlap between the two inequalities. So I should have this shape. Let's verify, and then we'll be done for today. So here's my line. I need a 0 for reference. I got a negative 8 and a positive 6. So we'll make the 0 right here. There's my 0. We'll do 6 over here somewhere, and I'm going to do negative 8 all the way over here. Close enough for me. So I'm going to graph these, check my solutions, make sure that they map out like I planned them to be. Use that dirty green again. So my solutions are less than or equal to 6. So I'm going to go to 6, make a nice dark circle. This one should be filled in, and my solution should be this way. Again, less than or equal to. I'm going to go to my 8. My solutions are greater than or equal to negative 8. Okay, it's equal to, so I can make a nice little darkened circle there. And they should be greater than. So what I find then is that my solutions make that barbell shape. Okay, I'll use this green here, help out a little bit. Make this barbell shape that I'm looking for. So again, let's review the rules. We'll scroll up to the top again. That's all you need for all of these. It doesn't matter what it is. If you can master these rules and you can follow them, just like baking a cake, you're set for these. Okay, again, the rules are solve for the absolute value first. Okay, after that, write a positive and a negative version of that function, right? Make sure that you use parentheses with that negative. So you go ahead and clean that out correctly. And then finally you solve for the variable. All right, that's it for today, guys. You guys have homework. It's in the packet right behind this. Plenty of practices or plenty of things for you to do. Again, go to my YouTube site. I think it's important for this one to see it a few times. I wouldn't tell you that if I didn't think so. So go to the YouTube site. Make sure you watch it. If you have any questions, post them on the Google community. I will be available.